Hello everyone, my name is Mohammad Atif and today we are going to understand two topics in physics. The first one is work and the second one is energy. Now this term work we have heard a lot of times in our daily life. Like I go to work, I am doing a workout. But what does this work mean in physics? Well, in physics it has similar meaning, but there are some differences. And what are the key differences we are going to learn today? So I have prepared a checklist for you. And what I'm going to do is I am going to perform some activities where we will have to check if this checklist is being completed or not. So the first one is force. So you have to check for the force. The second is motion and the third is displacement. Okay, I'm going to start first activity now. I am going to push this wall. Okay, I will apply all the force in my body and you have to observe the checklist. So I am pushing this wall, but is this wall moving? No. So in that activity, I applied force. So I can check. But was there a motion? Did the wall move? Actually not. Wall did not move and there was no displacement. So because of this, I can say that the activity that I performed, I did not do any work. Got it? Now I am going to do a second activity. In the second activity, there is a duster. Okay? Now I am going to push this duster. I pushed. The duster moved from this position to that position. Did I apply a force? Of course I did. Was there a motion? Yes, the duster moved. And there is some displacement. There is some displacement. So I can see that in this activity where I moved this duster, I did some work. Okay, you might be confused. So a work is said to be done when we apply force and the body moves in the direction of force. Now this term, in the direction of force, what does that mean? So I mentioned it here as well. Okay, how will we check? So for that, I am going to do the third activity for today. I am going to hold this bottle. Okay, I am holding this, so the direction is upward. I am applying a force upward to hold this bottle. But if I move in this direction, so my motion is in this direction, leftward, and the force that I am applying on this body is on upward direction. I can make a graph as well. So my force is in this direction, but the motion is this direction. So the direction is opposite. So I can say that I did not do any work because the motion is not in the direction of force. So we will look what is the unit and the formula for work done. So the unit is joule and the formula for work done is FD cos theta, where F represent force, D represent displacement, and this cos theta, you are familiar with this in the trigonometry. So theta is the angle between force and motion. We will do one numerical question so that you get a clarity. The question says a person pushes a box with a force of 20 Newton. So he has applied a force of 20 Newton. Okay. So there is some force. On a straight surface, the box moves 4 meters. So there is a displacement of 4 meters in the same direction. Calculate the work done. We have to find what is work done. So we can find work done by using this formula FD cos theta. FD cos theta. Okay, what is the angle? So they have told us that the direction is same. So when the direction of the force and the motion is same, so that means this theta will be what? 0 degree. There is no angle. So W is equals to F, we will put in place of F, what is the force? 20 Newton. And then D, that is 4. And cos theta, it means cos 0. Okay, 20 times 4 is 80. And cos theta, cos 0 is 1. So 80 times 1 will be 80. And the unit is joule. So this is how we can calculate that what is the work done in this particular question. Now I am going to do one more question with an angle. So we are going to do the second question. A porter carries a bag of 10 kilogram on his head and walks 10 meter forward. And we have to find what is the work done by the porter. Okay. So what is the force here? Okay, this porter, this our cute fellow porter is carrying this bag of 10 kilogram. So what is the force he is applying? We know from the first chapter motion that when you are carrying something, you are applying a force that is equal to the weight of the object. Now what is the weight of the object? This is a small w, will be equal to the mass of the object times its gravity. Okay, what is the mass? Mass is 10 kilogram and gravity is 9.8 meter per second square, and we can find out that this is 98 Newton. So this is the weight, the force that this porter is applying on this bag. So our force is 98 Newton and it has moved, the displacement is 10 meter. So it has moved 10 meter from there. And now we have to find how much work he has done. Okay, what is the angle? Can we discuss about the angle? So force, he is applying a force in upward direction. The direction of the force is upward and he is moving the bag in this direction. Okay, so the angle will be 90 degree. So theta will be what? 90 degree. Now we'll apply the formula. W is equals to Fd cos theta. So the force is 98 Newton, force is 98 Newton, displacement is 10 meter, and cos, we will put 90 in place of theta. Now I don't need to calculate this because cos 90 is 0. So 0 times 10 will be 0 and 0 times 90 will always be 0. So that means that our cute little porter has not done any work because he moved this suitcase in rightward direction, but he's applying force on the upward direction, as I told you. So now we will move to energy. What is energy? So energy is said to be the capacity to do work. So we learned about work. Now we will learn about this energy. I am going to perform one more activity so that we get an idea. So I am going to push this chair. So I am pushing this chair. And now I am so tired, I cannot push it anymore. What happened here? I pushed this chair from that position to this position. So I did some work, I applied force, the chair moved. And how did I do work? I used my body's energy. Now I am so tired that I cannot move it anymore. I cannot do any work because I don't have any energy. So this is what the definition means. Capacity to do work. If I don't have the capacity, if I don't have energy, I will not be able to do any work. And we are going to learn about two kinds of energy. The first one is kinetic energy and the second one is potential energy. And obviously the unit is also joule. So work done as and energy as same unit. So kinetic energy means that the energy of motion. For example, any object that is moving has some energy. And for this I am going to do one more activity. I am going to move this globe, and this is a box. We'll see what happens. So I move this and it was in motion and it collided with this small box and it moved from this position to that position. So it moved. It means this did some work. This ball did some work. Now this ball has to have an energy to move this. How did this happen? Because it was in motion. So the ball was moving, and that is why kinetic energy is said to be the energy of motion. Whenever an object is moving, it has energy, and this is called kinetic energy. The formula is now we will move to the last one, that is potential energy. What is this potential energy means? It means stored energy, the energy that has been stored by an object. And for this we'll do today's last activity. So to understand potential energy, so potential energy is the stored energy. So this ball is here if I move this ball, it has gained some energy because its height have been lifted. It has some stored energy. How can we see that? If I drop this ball on this object, see what happens. Okay, now that box just flew in that direction. And how did it move? Obviously it moved because the work has been done on that box. And who did this work? This ball. And but this ball was like on my hand, so it was on a particular height. So because of its height, it has energy. So if I lift an object, it stores energy. So this is what a potential energy means. We see this example a lot of times when we see a hydraulic dam. So the water from the glaciers or from for the rivers, like coming from the channels, we see that when water is falling, so it has an energy, and we convert that energy to electrical energy. So this is called potential energy. So I think we have learned a lot about what is work and how that is related to. Thank you so much for watching.